Hi, hello, and welcome. I'm going to run through an example cumulative stoichiometry problem, looking at how it's going to be on the Google Forms because I did have to set it up a little, it's a little weird. So we're going to go through an example problem so you can see how to correctly put in your answers. And also we're going to, for the first time in these videos, go through excess reactant and percent yield. So let's start with the first problem here. So this is what it's going to look like. The first problem is going to say, based on the following reactants, which is located here, predict the products and balance the equation, then select the choice that lists the correct coefficients for the balanced equation. Now, because that's a little difficult for me to put into a Google form, I did have to kind of create this chart here. So I'm going to go over how to navigate this. This is probably the most confusing part. So let's start by writing out our reactants. So our reactants are right here. So we have potassium, which we know to be K. It is reacting with nickel to bromide. Now nickel, we know, is Ni. This Roman numeral 2 is telling us that the nickel has a +2 charge. Remember, nickel is a transition metal. It can have multiple charges. And it is bonded to bromine, which is a -1 charge. Now, because that is a compound, we do need to crisscross those charges. So it becomes NiBr2. So those are our two reactants that were given to us. The next step is to predict the products. Now I see that this is a single replacement reaction. If you were to look on your activity series, we know that potassium has to be higher up on the activity series than nickel in order to replace it. And if you look at your activity series, you would find that it is. So the potassium is going to kick out the nickel and it's going to bond with bromine. And whenever we make a new compound, remember that we need to crisscross those charges. So potassium is in group 1, that has a +1 charge, and bromine would have the -1, just like we found here. And since those are equal and opposite, they cancel out. We're left with just KBr. And the nickel, since it got kicked out of its little relationship, is by itself. So that is our equation. We wrote the reactants, predicted the products, and now we need to balance it. Balancing this one is a little bit easy. I'm going to go through it the long way, so if you need to skip over this, you can. So we have potassium, we have nickel, and we have bromine. 1 potassium, 1 nickel, 2 bromine, 1 potassium, 1 bromine, 1 nickel. So my bromines are not balanced. Go to the side that has the lesser amount. What can we put in front of this compound that we can multiply in order to get 2 total bromines? We can put a 2 here. That gives us 2 bromines. Also gives us 2 potassium. So now our potassium are not balanced. So let's go to the side with the lesser amount. What can I put in front of the potassium to get 2? We can put a 2 there as well to give us 2 potassium, and now we are balanced. Okay, so we are going to look at this balanced equation here. And we need to put this into our Google form as an answer. So the way that you do this, it gives you the 2 reactants. So we have potassium, we have nickel 2 bromide. And then we have our product 1, which is the one containing potassium, and product 2 containing nickel. So we look at the potassium as a reactant. The coefficient is a 2, so I'm just going to click on the 2 for the potassium. Nickel 2 bromide does not have a coefficient, so that is going to receive a 1. The first product containing potassium is going to get a 2 because there's a coefficient of 2 in front of it. And then the second product containing nickel, that has a 1. Okay, so that's the way that you would navigate this first part. You do have to put in a number for each of the reactants and products, and if there is not a coefficient, you put a 1, okay? And you shouldn't need to go beyond 6. The next step then is to find the limiting reactant. So we have 10 grams of potassium and 50 grams of nickel 2 bromide. So I'm going to set up my dimensional analysis. If you need to use this sheet, you by all means can. We are going to start in the upper left-hand box with one of the 2 reactants. So I'm going to just start with the 10 grams of potassium up here. And then we are going to do, so potassium is my X, and my Y, so I'm starting at potassium and I'm going to my other reactant because I'm trying to find the limiting reactant. So I'm going from potassium to nickel 2 bromide, which will be my Y. So first I need to convert grams of potassium into moles. So I need to find the molar mass of potassium, which I would use my periodic table for. So potassium is right here. It says 39.098, so we'll round that to 39 grams per mole. So 39 would go into this blank here, so I'm going to do 39 grams of potassium in 1 mole of potassium. So now I'm here. My next step is to go from moles of potassium to moles of nickel bromide. So this is where you use the mole-to-mole ratio from the balanced equation. So I'm doing moles of potassium down, and I'm doing moles of nickel bromide up. So I'm using the balanced equation. So the coefficient in front of the potassium is 2. So that 2 goes down here at moles of potassium. And my coefficient in front of the nickel bromide is a 1. So I put the 1 by the moles of nickel bromide. So for every 2 moles of potassium that I put into this reaction, I'm going to also need 1 mole of nickel bromide. That's a ratio. So now I'm in moles of nickel bromide. I'm here. I'm going to now do moles of nickel bromide down, and I need to use the periodic table to calculate how many grams are in 1 mole of nickel bromide. So I'm going to do my 1 mole down, and I need to figure out how many grams are in 1 mole of nickel bromide. Now, nickel bromide contains nickel and also contains bromine. We have 1 nickel and we have 2 bromine. Now, nickel, if we look on the periodic table, is 58.7 grams, and I'm actually going to keep it at 58.7. And then bromine is 79.9, so we'll round that to 80. Okay, so we have 58.7 plus 160. I'm gonna plug that into my calculator. And we should get a total of 218.7 grams of nickel bromide. Okay, so let's go through and make sure that everything is canceling out. Grams of potassium, moles of potassium, moles of potassium, moles of nickel bromide, moles of nickel bromide, left with grams of nickel bromide, which is what we want. So we can go through and we can plug that into our calculator. So we are going to do 10 times 1 times 1 times 218.7 divided by 39 divided by 2 divided by 1 equals 28.04. That's grams of nickel bromide needed to react all of the potassium. Okay, so this is how much we need. Looking at the problem, we have 50 grams of nickel bromide available. So if we have 50 grams of nickel bromide, but we only need 28.04, then this is going to be our excess reactant. We'll have some left over. Therefore, potassium is going to be our limiting reactant. So I'm going to bubble in potassium as our limiting reactant. Okay, moving down, we have done this problem before as well, but it's asking, using the limiting reactant, how much nickel will be produced. So I'm starting with the limiting reactant, which we just found was potassium. So I'm going to start again with the 10 grams of potassium. And we are going to go through the same process, but instead of going to nickel bromide, we're going to start at the potassium, and we are going to the nickel. So I'm starting with the 10 grams of potassium. So that's here, we are given 10 grams of potassium from this problem here. I'm going to do the molar mass of potassium, how many grams are in 1 mole, which I did right here, so I'm just going to copy that down. Then I need to do that mole to mole ratio. So I need to figure out how many moles of potassium and then how many moles of nickel that would produce. So that's where we use again our balanced equation. So we have moles of potassium, 2 moles of nickel. So we use the coefficients. So for every 2 moles of potassium, we are going to produce 1 mole of nickel. Okay, and now we are in moles of nickel. We are here. So we need to use the molar mass of nickel to convert from moles to grams. So I'm going to do 1 mole of nickel down. And I'm going to use the periodic table to figure out how many grams are in 1 mole of nickel, which we already looked at, but it is 58.7. I'm going to keep it at 58.7. Okay, so our grams of potassium cancel out, moles of potassium, moles of nickel, left with grams of nickel, which is what we want. That's what all these answers are in. So I am able to now plug it into my calculator. So I'm going to do 10 times 1 times 1 times 58.7 divided by 39 divided by 2 divided by 1, and I get an answer of 7.53. We'll round that to. If you notice, I usually round to 2 decimal places in every answer I give you, so 7.53 grams, and that is right here. Now, if you were to have rounded this to 59 instead of keeping it at 58.7, you would have gotten a little bit of a different answer. So let's just see what you would have gotten here. 10 times 59 divided by 39 divided by 2. So you would have gotten an answer of 7.56 instead, but you notice that 7.53 is the closest to that answer, so you would still choose this. Okay, so if you do some rounding that's different than the rounding I did to put these answers in, just pick the answer that is as close to your answer as possible. And if you don't have a possible answer that's close, so let's say instead of 7.53, you got like 3.53, that's not very close to this. You might want to check your work because you probably did something wrong. Okay, so let's go on down to number 4. Number 4 is asking us how much excess reactant will be left at the end of the reaction. Now, in order to find how much will be left, we need to remember how much we started with. So let's look back up here where we did our limiting reactant work. We found that nickel bromide was our excess reactant. And in the problem, if you remember, we were told that we were starting with 50 grams of that. Okay, so we are going to start. Whoops, that's a T. So we started with 50 grams of nickel bromide. okay? To figure out how much nickel bromide was used in the reaction, we would have to go through reaction stoich, starting with the limiting reactant and going to find how much of this nickel bromide would be used. You guys are very lucky because we already did that work up here, right? To find the limiting reactant, we found how much nickel bromide was going to be used to react all of this potassium to nothing. So we already found out that there was 28, so we are going to use 28.04 grams of that nickel bromide in the reaction. Now, if we didn't do this, if maybe we flipped it and we started with the nickel bromide and went to potassium, we would have to then go through reaction stoich from the limiting reactant to the excess reactant to find out how much was used. But because we were lucky and we chose to start with the limiting reactant just by chance up here, we don't need to do that work again. You just get the same answer anyway. So if we are starting with 50 grams and we used up 20.04 grams, all we need to do is subtract those to find out how much nickel bromide is left. So I'm just going to do 50 minus 28.04 to get 21.96 grams of nickel 2 bromide left at the end of the reaction. So if we look at the question, that is one of our choices. I'm going to click on that and we're going to move on to number 5. Number 5, we are working with percent yield, which again is new. So it's asking if through experimentation you actually get 11.25 grams of nickel, what is your percent yield using this equation below? So we calculated how much nickel we are supposed to get up here for, this was number 3. So we theoretically should get out 7.53 grams of nickel through this reaction. Okay, so this is going to be our theoretical value. So this is 5 down here. So our theoretical value is the one that we calculated. So that is 7.53 grams. And just a heads up, this will always ask you about the product you calculated in the problem where I ask you to do reaction stoich. So you most likely won't have to do any reaction stoich for the 5th question, just so you are aware of that. So that's our theoretical, what we calculated. In the problem, it's telling us that through experimentation, we got 11.25 grams. So our experimental value is 11.25 grams. So to find our percent yield, we take our experimental, which is 11.25, divided by our theoretical, times 100. Now, before you even plug that into a calculator, you should be able to tell that this is going to be over 100%. If I got out way more than I was supposed to, that's going to be over 100%. You can think of it like a grade. If you received an 11 out of 7 on an assignment or a test, that means that you got more points than was possible, which means that you have over 100%. Okay, if these were flipped, if the top number is smaller than the bottom, then it will be less than 100%. Okay, and the closer these two values are to each other, the closer to 100% you are going to get. Okay, 100% is perfect. So I'm going to just do 11.25 divided by 7.53, and we're going to multiply that by 100 to get an answer or a percent yield of 149.4%. So again, it's over 100 because my top number is larger. And look at that, that is an answer. So I'm going to click that and we're going to hit submit. And what do you know, we got all of our points. Okay, so that's how you are going to go through and do these stoichiometry problems. They are a little lengthy, Probably going to take up a lot of space in a notebook, but we should be okay with them. Okay, that's it.